We have reached the final lesson in our work with polynomials. I admit it was a long journey, and I hope I will be able to upload more regularly so that we can move on to more math soon. But first we have to finish our introductory look at polynomial operations. This last operation I want to cover involves cubes, rather than the squares that we're so used to. Let's look at what we are going to explore today. I want us to start off by looking at this polynomial product. X plus 2 times x squared minus 2x plus 4. You might be thinking, this isn't a sum or difference of two cubes. And you're right. This here is something we've already learned to do in the beginning of our chapter, polynomial multiplication. Let's go ahead and multiply these two polynomials. Holding x plus 2 to equal a, we have a times x squared minus 2x plus 4. This equals ax squared minus 2ax plus 4a. This equals x plus 2 times x squared minus 2 times x plus 2 times x plus 4 times x plus 2. This equals x cubed plus 2x squared minus 2x squared minus 4x plus 4x plus 8, which finally equals x cubed plus 8. Do you see what we ended up with? Our answer is a sum of cubes. You can see it better if we rewrite it as x cubed plus 2 cubed. This means that x cubed plus 2 cubed equals x plus 2 times x squared minus 2x plus 4. And if we hold 2 to equal y, then our sum of cubes equals x plus y times x squared minus x times y plus y squared. There is a similar form for a difference of cubes. If the first two signs are swapped, we'll have a difference of cubes. For example, x minus y times x squared plus xy plus y squared equals x squared times x minus y plus xy times x minus y plus y squared times x minus y. This equals x cubed minus x squared y plus x squared y minus x y squared plus x y squared minus y cubed, which equals x cubed minus y cubed. The sum and difference of two cubes is a unique situation in that we can't prove them using the method of grouping that we used the previous few times. We had to work backwards, and thus was a bit ambiguous in what we had to do. Let's write out our definitions. Factoring the sum and difference of two cubes. X cubed plus y cubed equals x plus y times x squared minus xy plus y squared. X cubed minus y cubed equals x minus y times x squared plus xy plus y squared. These formulas can be difficult to remember at first. There's an easy acronym that may help to remember the placement of signs. SOAP. SOAP. It stands for same, opposite, always, positive. If we're working with a sum of cubes, the order will be positive, negative, always positive. If we're working with the difference of cubes, the order will be negative, positive, always positive. Only the first two signs swap, and the first sign will always be the same as the sign of the sum and difference of cubes. Let's work out a few quick examples. Number 1, x³ plus 27. First thing we need to do is get our cube roots. The cube root of x³ equals x, and the cube root of 27 equals 3. Next, our example is a sum of cubes, so our order of signs will be positive, negative, positive. Then our sum of cubes factors into x plus 3 times x² minus 3x plus 9. Number 2, 8x³ minus 64. Our difference of cubes has a coefficient on the first term. First, we'll get our factors. The cube root of 8x³ equals 2x, and the cube root of 64 equals 4. Since we're working with a difference of cubes, our order of signs are negative, positive, and positive. Therefore, our factored difference of cubes is 2x minus 4 times 4x² plus 8x plus 16. This is it on our chapter on polynomials. However, I may still upload one more video. If I do, it will be an unscripted worksheet video where I'll work out many different polynomial problems. I was thinking about using the OpenStax practice exercises since that is an open source book. If I do decide to do that video, it will probably not be my next one. Our next chapter will be on rational expressions. That is, expressions with polynomials in the numerator, denominator, or both. So stay tuned, you'll like these.